Welcome to App Modernization Approaches, Rehost, Replatform, Refactor. My name is Ram Kailas Nathan. I'm the Senior Director of Cloud Native Products. And along with me, we have one of our top internal customers from IoT Apps, Richard Baer from IoT Apps, and one of our SIs who's working with several of our customers for app migration, Avinash Shankla from Bias Corp. As part of this session, you will be taking home three key aspects. You'll be learning about the various approaches to migrate applications to the cloud. Through practical examples, we'll be sharing the tools, automation, planning, and process aspects of things, and then emphasize how you could be using a combination of these approaches to your app migration process, and that one approach does not typically work for all applications. Let's dive right in. As part of the keynote, Rajesh laid out all the approaches to app migration to cloud. However, he particularly emphasized Rehost, Replatform, and Refactor as the top three approaches. Rehost is basically moving applications to the cloud as is. It's popularly known as lift and shift. Replatform is basically lift, tinker, and shift, making minor changes to the applications and then moving the apps over to the cloud. Refactor is the major transformation effort that you typically take to convert your applications to cloud native. And then rebuild and replace are some of the other things that you typically look at for a very small subset of your applications. Rehost, as I mentioned, is the simplest of the three approaches and is particularly suited for applications that don't require weekly or monthly release cadence. The biggest benefits include speed of migration, time to market, reduced overall risk, and some of the challenges or risks associated with this approach includes slower pace of innovation because you're dealing with a very old architecture and an old set of brittle processes and possibly even technical debt. Replatforming is basically lift, tinker, and shift. And applications in this category go through some minor modifications to take advantages of the cloud attributes such as elasticity, but don't go all the way to cloud native. Again, in this case, the major benefits include relatively a quick migration path, and you get benefit, time to market benefit. And then the major risks include, again, dealing with old architecture and processes that are not very modern. And these two aspects eventually or typically hurts the pace of innovation of a particular application. Then we get into the refactor, which is basically re-architecting and rewriting the application to convert them into cloud native, really taking advantages of all the cloud attributes, including native elasticity, agility, and speed. And this also entails typically utilizing a pipeline with a combination of continuous integration and continuous deployment for all of it leading up to a rapid innovation, and also weekly to monthly release cadence, and basically taking advantages of all the cloud attributes. The risks associated with this approach include requiring higher set of skills for the initial effort. Also, the initial effort is very resource intensive. And so those are a couple of risks that people need to consider when taking this approach. Now I want to transition. I can talk about many of these aspects from a process and from a theoretical standpoint, but I really want to give you a real feel for this. And so we want to essentially leverage the next major portion of this session and presentation, really diving deeper into some of the practical sort of scenarios and examples by letting Richard and Avinash really call out their experiences. So with that, I want to invite one of our top customers, Richard Baer from IoT Apps.
Thanks, Ram. Yeah, let me start by just introducing a little bit about the IoT product and what it was like for us to move to these cloud native technologies. So our Internet of Things intelligent applications are all designed around solving business problems for our customers, being able to collect sensor data and device data and other data, mash it up, do analytics, and a lot of the other sort of advanced use cases to try to bring that intelligence from the edge into your business application space. So our product uses a bunch of different cloud native technologies from Linkerd and Kubernetes, which really, Kubernetes forms the foundation of our system that we deploy on. And then Prometheus and Thanos and Jaeger, which are all great tools for being able to inspect your system, gather metrics, and be able to really understand how your system is behaving when it's deployed. All these different technologies are a vital part to what we're doing. I'm going to switch over real quick just to a quick demo that we will come back to again a little later. And this is just one small part of our product set. We have a simulator. And in this simulator, this is our IoT digital twin simulator. And it has this nice UI and some information on what kind of messages are coming through. And if we go look at one of our simulated objects, we have some visualization of this guy and some information about some of the device data that he has. So we have some temperature and vibration and some other things like that. And we can look and see what the data has been for this guy over the last little while. And we can also simulate various different failure cases, like say there was a motor failure that occurred, and we can see what effect that's going to end up having on these different sensors. And we can come and look and see that the HVAC has stopped spinning as a consequence of that. Or we can, cause it to short circuit and see what that does to some of the different sensors. So this is one aspect of our application where we're able to take some big expensive piece of equipment, simulate it. All that data is being sent into the cloud. All that data is being analyzed there and is able to be reported as part of a particular application. For example, if you were a customer of Oracle Service Cloud and your company had these HVAC systems, you would be able to see what the status of your HVAC systems are at any given point in time. Now, as I mentioned, all these things are actually deployed in Kubernetes. So I have an example here environment that I'm going to be using for my demo today. And here you can see I'm using the kubectl command in order to get a list of all of my pods. And I can see some of the different pieces of technology that we're running inside of our system. And because this is Kubernetes, we have the ability to inspect any one of these pods, see what their events are, see what their status are, see what their logs are, and so on and so forth. So we're gonna come back to this demo a little bit later when we start talking about monitoring and how we end up doing our actual deployments in the cloud. So we have a pretty large installation of Oracle Kubernetes engine, the container engine. We have over 17,000 cores spread across 50 or more Kubernetes clusters. So it's a fairly large installation. We've been running this at scale now for a year and a half. We have a bunch of customers. And so for us, the really important things that we've learned over the last year and a half have a lot to do with how do you manage this thing at scale? How do you make it work in a production environment? And what were some of the lessons that we learned as a consequence of that entire experience? So as I mentioned, the Oracle IoT Intelligent Applications is cloud native. We use OKE on OCI for everything that we do, from development to testing to staging and our production workloads. We use a container-based workflow throughout the whole process in our CI/CD pipeline. And there's a bunch of different projects that we're using from the CNCF in combination with Kubernetes. So we have FluentD that we use for logging. We are using Jaeger and open tracing for doing our tracing between our different microservices. We have Calico for network policy between the different namespaces and pods that are running inside Kubernetes. We are using Prometheus for monitoring all of our metrics, and I'll show a little bit more of that later. And we also use Thanos over top of Prometheus as a single pane of glass so that we can see what's going on in all those clusters. As I mentioned, we had over 50 clusters and hundreds and hundreds of service instances. And so it's really important for us to have that ability to monitor our system and see what's going on. We also have a combination of different microservices that fit into our products. We're using Helidon and Java 11 for most of our microservices. We also have Node.js for the user interface components that we're building. And we also have some Golang or Go microservices. But it wasn't always this way. We started off in 2016 delivering everything on virtual machines. And all the development happened on our laptops. And it didn't always work out so well for us. The typical problems that we encountered are the same things that probably everybody here has experienced at some point, where development is in one environment and staging and production are in a completely different environment. And there's a lot of issues that you don't ever encounter in development that you end up encountering in staging and production. And that really makes it more difficult to get to the bottom of it. Like, why did it fail? So there were some issues that we had with this way of developing things. One of the reasons that we had to do it this way was because bringing up our entire system was very costly. There were lots of dependencies, and they were, large, and you just had your little laptop, and there just wasn't enough space to bring up everything that you needed to bring up to test it completely. So this was a big concern for us. So in 2017, we started developing and testing everything in Docker. We still had production-based systems that were based on virtual machines, but we did start to get consistent environments for our dev and QA. So we could replicate the experience, at least at that level. But it didn't always work out for the same reason that it didn't before. Our production environment was different from our development environment, enough that there were issues that we would run into production, and then developers would have to come in and try to figure out what was going on, and it was more difficult to handle. So in 2019, when we moved from our previous cloud, OCI Classic, to OCI, we took that opportunity to re-platform, and we moved on top of Kubernetes. Now, fortunately for us, we already had done the work in 2017 to run inside containers, so it was a more modest re-platforming job in order to run on top of Kubernetes. But it wasn't trivial. There's a lot of things that you have to deal with when you're running in production on Kubernetes that's different than what you deal with when you're running in virtual machines. In Kubernetes, you use Prometheus for your monitoring, for example. On virtual machines, we had some other technologies that we were using. So there were things that needed to be learned. There were definitely learning experiences in the whole process of going out container native in 2019. However, it's working out a lot better for us because we do have consistency between our dev, our QA, our staging, and production. They're almost identical, and we are able to catch issues in development that otherwise we would have, run into in production. So this is obviously an improvement. So here's another thing that I've mentioned a couple times that was really a big win for us when we went cloud native. And that was the ecosystem of technologies that are available to us once we were running inside Oracle Kubernetes engine. And Prometheus is one of those. So Prometheus is a Basically, it's a big metric store. It's a big, basically, key value store that you can run inside your Kubernetes cluster. And out of the box, Prometheus gives you many metrics on the Kubernetes cluster. It'll tell you how many pods you have. It'll tell you for each pod how much CPU it's using, how much memory it's using, and it'll do the same for namespaces and you know, the nodes that are in your cluster. It gives you a lot of information on what's going on just for free. So that was a really nice win. It was pretty easy to set up. And when we did, we were able to get some decent metrics. And anybody who's done this sort of thing at scale, you know how critical the metrics are to your success in operating a system at scale. Without metrics, we would have no real visibility into what is going on. And our customers could experience problems that we don't even know about or are aware of. And then that creates a poor user experience. So metrics is a really key part to us. And the fact that Prometheus just kind of works out of the box in Kubernetes is really a nice feature. We also, a lot of the ecosystem too is designed to work with Prometheus metrics these days. So the Helidon microservice container that we use has built-in support for Prometheus metrics as well. What this means is that Prometheus is able to automatically start collecting the statistics and metrics that are related to Helidon. So we can get numbers of requests per second and, you know, memory and a bunch of other things. And there's a metric framework that comes with it that using the microprofile specification that allows us to create our own application level metrics. So it's not just infrastructure level metrics, but app level metrics as well that we're able to capture and report into Prometheus. We also have written custom exporters for Prometheus that give us visibility into the autonomous database and other services that are sort of external to our code. And so Prometheus allows you to do that as well. And all this data is being collected and stored in each one of our clusters. Now, that's great, except like I said, we had 50 clusters. And so going to each individual cluster to see what its health is and situation is a bit cumbersome. So there's another technology in the cloud native toolbox called Thanos, which is associated with Prometheus. And essentially Thanos is a query layer on top of Prometheus. It talks to each one of those different Prometheus instances and each one of the different clusters. And we can go to Thanos and we can issue a query and get back alerts and other sort of data across all of our Prometheuses. And that allows us to then plug that into our Grafana and we get visualization of our entire system. And then the last piece is the raising of alerts. Prometheus comes with an alert manager, excuse me, and the alert manager is able to watch those different metrics. And if those metrics are out of bounds for a given period of time, or if they simply cross a threshold, or if there's a few alerts that are both going off at the same time, you're able to raise an alert. And that can be plugged into Slack or PagerDuty or email or various different means for raising alerts. So this really forms the basis for how we're doing our operations. And what I would like to do is to switch over to our actual Prometheus, I should say Grafana dashboard for this service instance that we're running. So if I come here, this is a custom dashboard that we created inside our Grafana that shows us some of the different components that we have inside of our system and the status of those components. And if we come down, we can also see their CPU usage and also the memory limits that are for each one of the different components that we have in our system, and the overall usage of everything, HTTP error rates, you know, our golden signals as such. And this is really, really powerful because we're able to switch across any of our clusters, and we can also switch across any of the installed service instances in any of these clusters and see all of this information. We also have higher level dashboards that work across all of these instances. And okay, so this is the fun part of the demo. We're gonna go kill something and hopefully see that we encounter some sort of a problem over here in our monitoring. So let's just do something. Okay, so I deleted one of my pods. Now, the interesting part about this is that one of the great features in Kubernetes is that it maintains what are called deployments or stateful sets, two different concepts, but they have a similar behavior, which is that they have a certain number of replicas that they want to maintain. And if that one of the pods goes down and the number of replicas is not being met, it will automatically restart that pod. So I'm coming in and I'm deleting a particular pod. And Kubernetes is going to automatically recognize that that pod has been deleted. And when it does, it's going to automatically create a new one. So let's go ahead and come in here and see. We should see it starting to come up. So you can see that the one that I created here is already coming back up. It's been starting now for 14 seconds, but it's currently offline. So when it comes to the monitoring, part of the fun of this is that one of the things that's really cool about this system in Kubernetes is that if you have really nice liveness probes and readiness probes, you can actually, things can stay alive in there to the point where you don't even end up with the alert at the operations side. If it comes back up quickly enough, it will happen within the polling interval that Prometheus runs in, and you won't actually ever see an alert show up on this side. But the alerts do come up here if it's down for a significant period of time. And there are moments when some systems will do that, where they are not behaving right, but they're not actually dead. And in that case, you end up seeing something showing up over on the monitoring side. So let's check and see what the state of this guy is. Yeah, he's already almost back up completely now. So we may not actually get to see the status change over on this side. But you can see here's an example of a service that is experiencing some outage. This is a development instance, so one of the developers is working on it, and in this particular instance that they have a health check that's down. So this is a good example. And over here you can see the alerts, and these alerts are things that we've configured inside Prometheus so that it will raise alerts that something is wrong. So this is kind of what you would experience in the case of an outage. So all that is capabilities that we get from these cloud native technologies. We didn't have to develop any of it. We just had to configure it and create our own dashboard to get some of the customization that we wanted. But it really comes with our cloud native stuff. So here's another big win, and I kind of mentioned it there a little bit during the demo, is that Kubernetes brings all of these automated operations along with it. We don't have to go manually bounce servers all the time. So Kubernetes gives you two different types of probes. There's a readiness probe and there's a liveness probe. The liveness probe just checks to see, is this pod failing? And it will automatically delete that pod and replace it when they fail in order to maintain the right replica, the number of replicas. As I mentioned, with deployments and stateful sets, they have a certain number of replicas. Kubernetes is going to try to keep those number of replicas there all the time. And the liveness probe is what it uses to decide if something needs to be replaced. Now, the liveness probe is totally under your control. You can have the liveness probe just poke a TCP port, or the liveness probe could issue a REST call and require a response. It could require a response within a certain period of time. It could require a response with certain payload, and all kinds of things can be done for that liveness probe. Essentially, it puts control in your hands to decide whether your pod is alive or not and needs to be replaced. So this can really reduce the number of times that you have to go manually do some sort of operation on your system, and it can continue to run, especially if you've designed your system so that it's highly available to begin with. when one pod gets recycled, the customer never even sees it, never even knows that has happened. So it's a really powerful feature. It's one of the things that was really appealing to us when we were evaluating Kubernetes. Kubernetes also has this thing called a pod disruption budget. And the pod disruption budget allows Kubernetes to know how many pods in that deployment or stateful set can be down at any one time in order to avoid service disruption. So it's just another tool that Kubernetes uses to try to manage your deployment to make sure that it is highly available and that your customer experiences no service disruption. And you might wonder if you haven't used this system before, you might wonder, well, why is that important? You know, under what circumstance would Kubernetes be taking down multiple pods? And it's useful for Kubernetes to know about the pod disruption budget because in Kubernetes, you have a bunch of either bare metal machines or VMs that are called nodes. And those are the machines that are going to run all your Docker containers that form your Kubernetes pods. And so a pod in Kubernetes is essentially a collection of Docker containers. And a node in Kubernetes is basically like a VM or a bare metal machine that's going to run those containers. And sometimes you need to recycle your nodes. Maybe you need to upgrade the operating system on them. Maybe you're changing the shape of the underlying hardware. You're scaling it in some way. There's various different reasons why you need to replace a node. And when you need to replace a node, all the containers that are running on that node need to go down and be restarted somewhere else. And Kubernetes has all this logic for rescheduling where the pods are going to be and so forth. When it has a pod disruption budget, Kubernetes can move as many of those pods off somewhere else at the same time as possible without having any sort of service disruption. So a pod disruption budget is a really nice tool that gives Kubernetes scheduler opportunity to do things in a smart way that prevents you from experiencing any kind of a downtime to your customers. And there's a bunch of different tools that kubectl provides for viewing logs, for listing your pod status, for viewing the different events that are going on inside your system, listing all the nodes and their status and everything else. So there's a lot of great tools there that you get for free. So in summary, for the IoT team, Cloud Native made our service much better. We have much better visibility in our service. The number of failures that we encounter has decreased, and we're better able to scale with the number of customers that we bring on. There are challenges to doing this sort of refactoring for the cloud. Training, for sure. There's a whole new set of technologies for the entire team to learn. So training is a big effort. There is a migration effort because we needed to move, customers that were in other places into our system. And also just, we had some on-premise technology that we needed to turn into containers until we can eventually replace them with some newer technology. So there's some effort in that replatforming. And there's also the case that there's like a lot of technologies in the cloud native space to choose from. So you gotta learn a lot about these different technologies, decide what you're going to use for CI/CD, decide how you're going to deliver your applications, decide how you're going to be doing all your monitoring, decide how you're going to be doing all your tracing, what kind of microservice containers you're going to use, or whatever you're going to end up hosting your stuff in. So there's a lot of pieces to it that you have to kind of assemble into a full tech stack. So I think those were the key challenges that we encountered. And with that, I'd like to turn it over to Avinash.
Thank you, Richard. So my name is Avinash Sankla. I'm a senior director with Bias Corporation, and I manage the cloud services and systems practice at Bias. Bias has been a platinum partner with Oracle, and given that status, we migrated numerous customers to the Oracle Cloud Infrastructure, and Bias has been awarded the OCI Partner of the Year from a global and North America perspective for 2019. Saying that, I think let's dive straight into some best practices and use cases relevant to OCI migrations. Richard, can you get to the next slide, please? Wonderful. So this is a great example of one of the customers that we worked with. They're a large US-based pharmacopoeia, And the key aspects to bring to the forefront relevant to this customer was, like most clients out today, they wanted to move to the cloud for various reasons: aging hardware, workload diversity, they want more performance out of their systems, they have critical workloads, so on and so forth, right? Uh, the important aspect to take a step to bring home over here with this customer was they had a huge infrastructure footprint on their on-premise data center. They had at least 10 environments of Oracle EBS, Oracle Analytics, Oracle Apex. They had custom applications. And when buyers came in the mix to help them migrate everything to the cloud, we of course used our accelerate methodology, which of course has 5 different work streams relevant to governance, security, infrastructure build, migration, and testing. And we help them move the entire stack up to Oracle's cloud infrastructure. The key aspect is rehosting, replatforming what was required relevant to their existing footprint that was on premise. And rehosting is basically moving your Oracle EBS applications like Ram talked about. Replatforming was moving them from their existing workloads on VMware and Solaris up to Oracle Linux in the cloud. And I think the outcome was great. They have a much more performant system. We increased system performance by at least 60%. They've got a pretty optimized and modernized cloud environment with fault tolerance, scalability, and DR across all their applications. Next slide, Richard. All right. This is another great customer story that we have to bring forward. This is a huge service delivery company with revenues close to about $70 billion with a global footprint. They have a vision of moving to a zero data center strategy. The biggest challenge, once again, as most companies in the industry today, is around workload diversity, aging hardware, data center retirement, so on and so forth, right? Everybody wants to reduce their operational expenditure going forward, and the move to the cloud is an apt form to get that. So from a buyer's perspective, we use the same approach again, the accelerate methodology, where we planned, we migrated and optimized depending on what was moved to the cloud. So in stage one, we picked up all the 196 odd custom applications, which were spread across the board. They had numerous databases, 60 plus databases were migrated across 450 plus virtual servers. The key aspect in this case was we had to group those applications early on, right? We had grouped them based on priority relevant to their importance, relevant to the complexity of what they brought to the table, relevant to how they were interconnected and interdependent with each other. And that grouping kind of helps out initially in the planning stage for us to map what needs to be migrated under what circumstance, right? For example, there were certain applications that were grouped in group one, which would be purely rehosted. Some would be refactored, and the others would be replatformed. So refactoring was a really great case where we actually took some of those applications, and in phase two, we're moving them to Oracle Cloud Native on Kubernetes containers that we heard Richard talk about. This is an ongoing exercise. We are in phase two today, and it's a very large footprint that we successfully migrated phase one, and phase two is going to give them a completely fault-tolerant, scalable, with a DR-based environment in Oracle Cloud infrastructure. The next slide, please. So, I mean, if you take home, what are the big key important considerations for moving to the cloud, right? Embrace the cloud is the first key factor we all need to keep in mind, and that's where clients are headed today. Create an exceptional customer experience for your business, for your users, right? Accelerate innovation, cloud to market, launch new products and services better. That's what the cloud offers to you. Your platform modernization, application modernization, and data modernization are key aspects to moving to the cloud. And Oracle Cloud Infrastructure offers you the right platform, the cloud native opportunities that you can use across your custom applications to move them to the cloud. And what paths to the cloud? You can modernize. The most important fact, is modernize your applications. But prior to doing that, modernize your roadmap, transform your blueprint. Make sure that your analysis phase and your planning phase is the key aspect and the foundation for what kind of applications you want to move. The other important aspect is to keep into account time considerations relevant to refactoring and rebuilding your application in the cloud. It is resource intensive, and you need to fully leverage your cloud native features relevant to processing and reviewing around them, and re-architecting and recoding. And like Richard also mentioned, the skill set uptake on that front is going to be you'll really require advanced coding and automation skills from a DevOps pipeline perspective. With that, Ram, I'll hand it back to you.
Thanks, Avinash. Really appreciate your background. Thanks, Richard, for the fantastic demos and the practical sort of experiences that you shared. With that, I want to sort of conclude by calling out the 3 key takeaways that we initially spoke about. Through this presentation, we learned about the various approaches to migrating to the cloud. And more importantly, through Richard's talk, we actually gained a lot of insight into the practical set of tools, automation, planning, and processes. Avinash, from an SI perspective, providing a lot of the process and planning aspects as well. And then the most important aspect to call out here is, we have a combination of approaches here that we can apply to every single application or a combination of applications. And from our experience, we can confidently say that one approach does not typically work for all the applications. So it's important to consider all the various tools that we have available. With that, we'll take some questions that we have. One of the first questions that we have is what are the top challenges? And I think Richard would be the best person to talk to this.
I think the top, in my experience, the top challenges of moving to a cloud native is the training aspect. I think that's been the most difficult thing, is to get everybody up to speed with the latest approaches. We had to make changes to our build system in order to create the containers and deploy them. So I think there's definitely some work on the build side, there's work on training side, and then just getting really familiar with it. I mean, my experience has been that learning a new technology enough to know how to use it doesn't take very long, but using a new technology to the point where you're comfortable deploying the thing in production, using it at scale and operating it 24/7, that's quite another story. So I think that you need to definitely give yourself a little bit of time to experiment with these technologies at under load and at scale, just to really make sure that you're comfortable with it before you put something into production on it.
Is it okay to use a combination of lift and shift and cloud native within the same application? Absolutely. In my experience of sort of onboarding many customers, both internal and external, we've seen several of the customers really taking that initial phase of bringing their application through the lift and shift approach, but then parallelly working on the new sets of roadmap features, utilizing the cloud native sets of tools and processes. So it is not uncommon to see both approaches being parallelly applied to the same application.
What is the most popular approach for application migration? Well, it all depends, right? It depends on your path to cloud. You would have a diverse kind of applications that you have across the data center. And I think the key aspect comes down to planning and analysis of what applications need to go to the cloud, number one, which applications are the right candidate to be re-architected or re-platformed or rehosted. So there are a couple of points we need to take into account. From an application requirement assessment, look at portability for the application, requirement for that application, the flexibility requirements from the application, elasticity and auto-scaling requirements of the application. Do you need dynamic on-demand scaling? Is it a high-intensive application that's required, or it's one of those background applications that you just need to keep running steadily? Do the analysis around effort versus cost, because going to cloud native or going into refactoring mode for an application is intensive. It's intensive, relevant from a cost and effort perspective. Like we've heard Richard and Ram talk about the requirements for advanced coding skills, automation, DevOps skills, CI/CD pipeline implementations across moving these applications. And most important is time considerations, right? Refactoring and rebuild will take much more, will be longer, because the re-architecting, going back to the drawing board before you move those applications to the Oracle Cloud Native, in that form, as compared to rehosting or re-platforming your application. At the end of the day, I think avoid over provisioning, right? be mindful of what your application requires and move from that direction. So there's no one popular approach to what needs to be done. It all depends on the kind of application you have, your requirements, and what you need to get out of it, and what advantages you want to get from the cloud. And what Oracle Cloud offers is the platform across everything from a tool perspective of what you can apply towards your applications to move to the